Wouldn't it be great if there was a way to take an instance of, for example, the order and define how this could be deconstructed into local variables? Just like we did with the tuple. The compiler doesn't do this for you, but there is a little bit of code that we can add to make it possible to deconstruct a class, interface, or even a struct. This is useful for a couple of reasons. You will discover one of the most useful cases in the next module when we introduce pattern matching. We'll take a sneak peek at that in just a moment. The goal is to be able to take an instance and deconstruct that into local variables. Let's say that you want to take the order and be able to deconstruct this into two variables, one representing the order total, the other if it's ready to be shipped. To achieve this, you can create an instance method that's void and called Deconstruct. If it's void, how do you define which variables are deconstructed from this instance? This is done using out parameters. You have to specify at least two parameters, otherwise you cannot deconstruct the object. Out parameters always need to be assigned a value, otherwise you'd get a compiler error. Let's go ahead and add this deconstruct method to the order and see how we can use this in the program. This is a public void method with the name deconstruct. Naming this correctly is important. Then make sure that you set all the parameters to out parameters and assign them to appropriate values. You could have anything as an out parameter. It doesn't necessarily have to be a property or field from this instance. It could be something that we compute or the result of an additional method call. For example, the parameter ready could be checking that both the isReadyForShipment property is true, as well as there being a shipping provider specified. Let's just check isReadyForShipment for now, and you can make additional experiments on your own. This deconstruct method is now complete. Because we've followed this pattern, the compiler will now know how to deconstruct this and generate appropriate code for us. Head over to the program and take an instance of an order. And we can assign the instance to two local variables, using the same approach that we did with the tuple. There's a slight difference here. This cannot be deconstructed into a tuple. It has to be deconstructed into separate variables. When the compiler sees the var keyword, followed by the variables that we want this instance to be deconstructed into, it will automatically generate code that simply calls the deconstruct method, using these two local variables as the out parameters. It's really just a handy way of getting an alternative representation of this class. Hence, it's deconstructed into a different representation. There is a way to combine this with using tuples. We can ask if the instance of the order is a match to a tuple with constant values. This will in fact check if the order is not null and if the total is above 0 and that it's ready to be shipped. Does this mean it would be possible to compare this against an instance of a tuple? The answer is no. If we look at the generated code, it may become clear why that's the case. How would you compare this to the generic value tuple, which would be generated if you defined a tuple? The code we used in the if statement is definitely something that we are going to explore in great detail in the next module. You may be wondering now if it's possible to have more than one deconstruct method. That is definitely possible. You just have to make sure that they have a different number of parameters. If you introduce an overload for deconstruct, It doesn't matter if the parameters have different types if they have the same number of parameters. The call would be ambiguous, and the compiler wouldn't be capable of determining which one to use. We can add an overload where the final out parameter is the items. If you then head over to the program, you can now decide which way you'd like this instance to be deconstructed. By changing the number of variables that you are deconstructing your instance into, it chooses the appropriate method. If you like, you can even ignore one of the values by using the discard like we've seen earlier, just as with the tuple deconstruction and the lambdas. Even if you use discard, it will call the method with those number of parameters. This means if you capture 2 and discard 1, it will call the method with 3 parameters. If you want to add the capability of deconstructing a type that you don't own, how do you think you'd do that? You can do this with an extension method. Let's add a deconstruct method as an extension method in the order extensions class. Since this is an extension method, it will be a static method, still using the name deconstruct, with the first parameter being the class that we are extending. Then, we can specify the out parameters, and they need to be a different number of parameters than what the other deconstruct methods have defined prior. This deconstruct will give us the order number, total number of items, the items, and an average price. By now, you should know how to call this. If you add an extra variable or discard, this will invoke the extension method. Being able to deconstruct an object into a local variable, you can make the code easier to read, which ultimately makes it easier to maintain and understand. As a final example of deconstruction, I'd like to highlight one of the use cases in .NET. If we have a dictionary of string and order, and we'd like to iterate through this, the generic key-value pair in fact implements a deconstruct method. This will let you deconstruct this key-value pair into 2 local variables. Why does this make a difference? If we iterate through the collection, we could say that the key is in fact the order number and the value is an order. The type of the value would have been quite obvious if we looked at the dictionary, but having this deconstructed into 2 local variables with explaining names makes a huge difference. Now you've seen how to work with tuples, how to return them, accept them as parameters, and how to work with deconstruction in different situations.